In Brazil, Bagasse, a byproduct from the sugarcane pressing process, is being recycled into biofood trays. This material has a short decomposition time, does not generate microplastics, and is considered one of the most effective alternatives to single-use plastics today. Right now, let's learn together about the process of processing bagasse into these biofood trays. São Paulo State, the agricultural heart of Brazil, accounts for over 50% of the country's total sugarcane production. This fertile land, with a humid tropical climate, average temperatures of 75 to 85 degrees Fahrenheit, and 47 to 59 inches of rainfall per year, is truly a paradise for sugarcane. From October to March the following year, millions of young sugarcane plants are planted over large areas. Each hectare of land will yield 30 to 40 tons of sugarcane after 12 to 18 months of growth, a cycle requiring patience and precise science. Throughout the growth period, each sugarcane plant needs a huge amount of water, about 59 to 79 inches per year. Smart irrigation systems with soil moisture sensor technology help optimize water supply, ensuring every drop of water is used efficiently. At the same time, organic fertilization and biological pest control are carried out regularly. When the cane stalk reaches a diameter of 1 to 1.5 inches and a height of 13 to 16 feet, they are ready for harvest. The harvest season arrives the most important moment in the production cycle. Instead of traditional manual methods, modern farms in São Paulo use giant combine harvesters, each capable of harvesting 66 to 88 tons of sugarcane per day. These machines operate 24/7, cutting cane stalks close to the ground, automatically removing leaves and loading cane onto trucks in a seamless process. Rapid harvesting speed helps maintain maximum sugar content in the cane, the factor determining the quality of the final product. Immediately after harvest, time is gold. Trucks full of sugarcane move instantly to the processing plant within 24 hours. The route from field to factory is calculated optimally to reduce transport time, because for every hour that passes, sugar content in the cane decreases by 0.5 to 1%. Giant trucks, each carrying 22 to 33 tons of fresh cane, form a long convoy on the highway, a ceaseless green flow nurturing the industry. Welcome to the heart of the transformation process, the modern sugarcane processing plant. When trucks loaded with cane arrive, they are weighed for quality check before dumping into a giant conveyor belt system. Each day, this factory processes 11,000 to 13,200 tons of fresh cane. Cane is washed clean with high-pressure water to remove sand and soil, then goes through a coarse shredder, cutting into small segments of 4 to 6 inches. This is the first step in the magical transformation chain. The most important step, pressing sugarcane juice. Chopped cane segments go through 4 to 6 giant pressing stations with pressure up to 2,200 to 2,500 psi. Each pressing station consists of 2 giant rollers rotating in opposite directions, crushing cane stalks and squeezing out every drop of sweet juice. The result? From 1 ton of cane, we obtain 145 to 185 gallons of cane juice containing 12 to 15% natural sugar, precious raw material for sugar and ethanol production. But the remaining part bagasse with 40 to 50% moisture is actually the star of today's story. Fresh bagasse is transported via a conveyor belt over 330 feet long to the industrial drying area. Here, a high-capacity hot air drying system uses temperatures of 180 to 220 degrees Fahrenheit to reduce moisture down to 10 to 15% within 30 to 45 minutes. This process is extremely important. Low moisture makes bagasse easier to grind and shape. Furthermore, high temperature naturally sterilizes, removing bacteria and mold without chemicals. Every hour, the system processes 22 to 33 tons of wet bagasse. Dry bagasse is now ready for the grinding step into powder. It goes through an industrial grinder with high carbon steel blades rotating at a speed of 1,800 to 2,400 revolutions per minute. Bagasse fibers are ground fine, reaching 80 to 120 mesh fineness, equivalent to particle size of 0.005 to 0.007 inches. This fineness determines final product quality. Fine enough to create adhesion when molding, but still retaining natural fiber structure, providing durability. This light beige bagasse powder contains 70 to 75% cellulose precious plant fiber. This is where the real magic begins. Bagasse powder is mixed with water in a precise 3-to-1 ratio to form a paste mixture. In industrial mixing tanks with capacity of 1,320 to 2,640 gallons, giant impellers rotate at 60 to 100 RPM for 15 to 20 minutes to create perfect homogeneity. Some advanced factories also add a small amount of natural plant-based resin, 5 to 8%, to increase water resistance. The final mixture has consistency like toothpaste, ready to be shaped into millions of boxes. The paste mixture is pumped to the automated molding line, the heart of the factory. This system includes hundreds of precision metal molds, each heated to 300 to 350 degrees Fahrenheit. Bagasse mixture is injected into molds under 140 to 180 psi pressure, filling every small gap. High pressure combined with high temperature makes water evaporate quickly. Cellulose fibers bond together, creating a solid structure. In just 45 to 60 seconds, a complete food container is formed. This line can produce 3,000 to 5,000 boxes per hour. Newly molded products are still hot and need to be cooled quickly. They move through a cold air cooling system with temperatures of 60 to 70 degrees Fahrenheit for 2 to 3 minutes. Proper cooling helps products keep their shape, avoiding warping or cracking. Then, each box goes through an automated quality inspection station using AI cameras and laser sensors. The system checks 15 criteria. Dimensions: error less than 0.04 inches. Wall thickness: 0.02 to 0.03 inches. Flatness: no cracks, holes. Acceptance rate: 98 to 99%. Standard boxes now need to be strengthened. They go through a high-temperature oven at 450 degrees Fahrenheit for 8-12 minutes. This process is called curing baking to perfect the structure. High temperature helps cellulose molecules bond tighter, increasing hardness and load-bearing capacity. As a result, the product can withstand weights of 20 to 33 pounds without deformation. After baking, boxes are coated with a super thin food-grade coating from natural carnauba wax or modified starch to increase water and grease resistance. Final quality check before packaging. The quality lab takes random samples every hour to perform strict tests. Drop durability test. Drop from 3.3 feet height onto concrete floor box, must not crack. Water resistance test. Soak in water for 24 hours. Absorbed moisture less than 5%. Microbiology test. Count bacteria number must be less than 100 CFU per gram. Food safety test. No heavy metals, no toxic chemicals. Only products passing all tests are approved for shipping. Finally, packaging. Perfect boxes are stacked automatically by smart robots. Each stack of 25 to 50 pieces is taped with 100% recyclable paper tape. Then, they are packed into large unbleached craft paper cartons, each carton holding 200 to 500 boxes, depending on size. Product information is printed on the carton. Production batch code, production date, quantity, storage instructions. Every day, the factory packages 50,000 to 80,000 boxes ready to transport all over Brazil and export internationally. From the factory, the journey continues. Container trucks carry thousands of box cartons all over Brazil, from Sao Paulo to Rio de Janeiro, from Brasilia to small remote towns. Some shipments are exported to Europe, North America, and Asia via Santos Port, the largest port in South America. These boxes made from Bagasse are replacing millions of plastic and styrofoam boxes each year, contributing to reducing 220 to 440 pounds of CO2 emissions per ton of product compared to traditional plastic. Supermarkets, food stores, restaurants, this is the final destination. Bagasse boxes appear everywhere. Fresh food counters holding organic salads, fast food counters holding burgers and sandwiches, high-end restaurants using them for desserts. Brazilian consumers increasingly favor green products. 68% of customers are willing to pay 10–15% more for environmentally friendly packaging. Retail price for businesses, only $0.08, 0.15 each, 20–30% cheaper than equivalent quality plastic boxes. After use, the final magic happens. Instead of lying in landfills for hundreds of years like plastic, these Bagasse boxes decompose completely in just 45–90 days under industrial composting conditions. At organic waste treatment facilities, boxes are shredded, mixed with food scraps and garden waste, then composted at 140 to 160 degrees Fahrenheit. Natural bacteria and fungi break down cellulose into nutrient-rich compost humus, an excellent fertilizer for agriculture. A perfect closed loop from sugarcane fields back to sugarcane fields. Impressive figures. In 2025 alone, factories in Brazil produced over 2.2 billion food containers from Bagasse. This figure is equivalent to saving 88,000 tons of plastic from being released into the environment. If stacking all boxes into a pile, it would be higher than 220,000 miles, enough to fly to the moon. This industry creates jobs for 15,000 people, from sugarcane farmers to factory engineers, contributing to sustainable economic development. This is not just a story about a box, this is a story about humanity's green future.